Okay, all right, let's just get on with it. Crude oil is a source of hydrocarbons, which can be used as fuels or for processing into petrochemicals. Octane, and then we have it, C8H18. Here we have the 8 to show us it's octane. It's one of the alkanes present in petrol. Carbon dioxide is formed during the complete combustion. We burning it. That's why I do chemistry. I get to burn stuff and blow it up. Oh, can I say that? Anyway, so what's the general formula for an alkane? The way I do this is if I look at this and here's my alkane thing, I look at how I get from 8 to 18. So the general formula for those who don't do maths is Cn. N being pick any number you want. So we've got an 8. And usually, actually all the time, within hydrocarbons, it's times by 2. So I got H 2N. So twice as many. This isn't writing very well, but let's see how it goes. So I got H2N. All right, let's change code to something like red. See if red sticks out nicer. CH2N. But 8 times 2 is 16. I don't want 16, do I? I want and I need 18. So, well, and to add 2. The general formula is CnH2n plus 2. Carbonyl. It's formed during the carbon monoxide. I don't know why I haven't said carbonyl. It's formed during the incomplete combustion of octane. Write an equation for the incomplete combustion of octane forming carbon monoxide and water. So I take it notes on here. So let's, no, it's still just me. So let's have a look. Where we write an equation for the incomplete combustion. So what I do is I'd look at this. I'm on the wrong. Then I'd look at this and I think, well, I am going to start with C8H18. It's incomplete combustion and I'm forming carbon monoxide. Well, in my equation, I'm going to form carbon monoxide and I am going to also form water. Alright? So that's what goes in my head. I've got enough oxygen to form water and not quite enough oxygen to form, oh my god, this is disgusting. Right, H2O. Oh, anyway, so, well, if I've got oxygen here, I'm gonna need oxygen to burn. Right, it's got to be O2, it can't be O. So I'll come back to my carbon monoxide molecule. Well, how many of them am I going to get? Well, I've got 8 carbon molecules, so I'm going to get 8 carbon monoxide. How many H2Os am I going to get? Well, I'm going to get half of the H18s here. Let's change a little bit to a little bit of purple. Let's get a little bit of purple here. I'm going to get half of these because I've got 2 hydrogens here, so I'm going to have 9 oxygens over here, 9 water molecules. I've got 9 water molecules. So then I've got to work out how many oxygen molecules I'm going to need. Well, I need 8 atoms here, and I need 8 atoms here and 9 atoms here. That's 17 atoms in total. Let me just double click. 9 add 8. Yep, it's 17. So that's an O2 molecule. So I need to divide this by 2. And that'll give me 8.5. Push my disgusting handwriting. There you go. Alright, let's have a look. Why does incomplete combustion sometimes take place? Well, there's lots of reasons for that. Let's pick a nice one. Why does incomplete combustion take place? I will simply for this one just put down. Yeah, either there's not enough oxygen. And that's the simplest. And we could, you know, add on to that. But the simplest answer is not enough O2. Oxygen, we'll write O2 because you don't know how it's disgusting. Okay. So let's scroll down. Let's just pop down and see if we can do the next one. No, we can't, not really. So what I'm going to do is, let's just check out how the hangout's going. And before we do it, let's get some more questions. So what I'm going to do is print screen, go over to paint it in. Who's here? No, it's still just me. Okay. And apparently this records straight to YouTube. It's a YouTube video, so my little darlings can have a look at that. So let's go back to, oh my lordy lord. What colour? Let's go for psychedelic green. All right. Let's select my pen. In catalytic the catalytic converter, two toxic gases, carbon monoxide, nitrogen monoxide, react together to form two non-toxic gases. So these are two toxic gases forming two non-toxics. Write an equation for the reaction between carbon monoxide and nitrogen monoxide in a catalytic converter. So the thing is, you've got to think what non-toxic gases can we form? Oh, that's a disgusting colour. Let's go back to something dark. So what carbon monoxide, I know we know carbon monoxide because it tells me these two react and nitrogen monoxide are. So what two gases do we know about that they could make? Well, carbon monoxide, that's very poisonous. The simplest thing to change that to is carbon dioxide. And a ton, nearly 80% of the atmosphere, is made of nitrogen. So we know, we should know that nitrogen is non-toxic. If it wasn't, we'd be dead. So you've got nitrogen gas, N2. So how are we going to balance this? Well, this is a little bit tricky because we've got N2 over here and we've got NO over there. So this NO, we have to have two NOs over here. So now we've got two oxygen atoms here and one there and three, and I can't do it. So what we've got to do is very carefully just count up the oxygens. If we've got two NOs here, I've got three in total, right? Three oxygen atoms. But I'm going to have two on this side. The mass side of me looks at this and thinks, ooh, 2 and 3. Lowest common multiple is 6. Now, what other ways are there going to be to do this? Well, we've got 3. We are going to, if we increase the number here, we're going to have to increase N2s, which you don't really want to do. So I'm going to have to increase carbon dioxide molecules. How many have we got now? 4. Is there a way of getting 4 over here? Oh, forget the 6 that I was saying. I don't know why I got 3 because, yeah, I did. I got 2, 3 there. I've got 4 here. The easiest thing to do will be to put 2 in front of your carbon monoxide. Why I was thinking of multiples there, I don't know. There you go. 2CO plus 2NO goes to 2CO2 plus nitrogen gas. All right, let's delete this chunk here. Yeah, it's going to look funny, but who cares? Right. Oh, well, it does matter. Where am I? There's my pencil. Okay, so outline stage that takes place in a catalytic converter to allow carbon dioxide to react with NO. So what happens, right? The first thing is that the CO, the carbon monoxide, and the nitrogen monoxide, these have to be, and the thing about catalytic converters is a massive surface area, and the reason for that is these two have to stick to the surface. I'm going to try not to use any technical terms because then it's easy to remember. Okay, so carbon monoxide and nitrogen monoxide got to stick to the surface. This weakens the bonds because these bonds are now suddenly weakened because they're held on the surface. It lowers the activation energy. I really got to sort this out in terms of my tablet. Right, activation energy. So lowers the activation and put E, energy, because you've weakened the bonds. Right. Now, I'm thinking, stick to the surface. Should we use a technical term? Yeah. Let's chuck it in anyway. Adsorbed. Okay, the final bit, the carbon dioxide and the nitrogen gas is released from the surface. The technical, what's the technical word for that? Is desorbs. Desorbs from the surface. Desorbs. Okay. What was that? Let me have a look back on this. Hello. I'm still broadcasting, and I've got one viewer. Ooh, I think that's just me. Is that just me? Well, I don't know. Anyway, so let's have a look. Let's have a look at the next question. Boom. I think I've drank too much coffee and I can't sleep. Oh, right. Let's look at the next question. So we're the catalytic converter. Right. Let's have a look at the next OCR question for Unit 2. There we go. All companies process hydrocarbons such as octane into branched and cyclic hydrocarbons that promote efficient combustion in petrol. Draw the skeletal formula of a branched hydrocarbon and a cyclic hydrocarbon, each containing 8 carbon atoms. Alright, so I'm going to branch. And what again I'm going to do is I'm going to try and pick the easiest. Right. So let's have a look. Yeah. I would, maybe need to do a really simple branch. I'll go 1, 2, 3. Ooh. So I'll do it now. Why not? 4, 5, 6, 7. Let's put one here. 8. And there you go. Why I felt that, I don't know. I just felt like it. A really simple one would have been 7 carbon atoms in a row. 3, 3, 4, 5, 6, 7, and I would just shuffle them there like a methyl group. Okay. The cyclic hydrocarbon. Now that's interesting. How would I want to do that? Well, what I could do is go 1, 2, 3, 4, 5, 6, 7, 8. There you go. Might not have. Well, that'll do me. That's cyclic and it's hydrocarbon. Job's done. Okay, let's get down to the next one. Some scientists believe that an increased CO2 levels arising from combustion of hydrocarbons lead to global warming. The CO2 is a greenhouse gas. Carbon capture and storage (CCS) is being developed as a method for removing CO2. Carbon capture and storage. Different gases have different contributions to global warming. So there are 2 factors that affect the contribution of greenhouse gas to global warming. You know what? I was thinking, I hope my writing's coming up on the YouTube video. I wasn't even thinking when I read that one. Okay, so there are 2 factors that affect the contribution of greenhouse gas to global warming. Now, just give me a sec. There's a really weird one for this, and for some reason it sticks in my head, and it's always sticks in my head, even before I kind of understood. Ability to absorb infrared radiation. And I remember learning this, and the reason why it stuck in my head was because I thought that's a weird way of answering the question. I don't know why it seemed weird, but it just since then stuck in my head. And afterwards, I don't know, a few hours or days or weeks or months, I actually understood what it meant. But when I mean understood what it meant is what actually happens to the bonds when infrared radiation is absorbed by the carbon-carbon bonds. But then again, I was a kid at the time. That was a very, very long time ago. And the other thing that affects it is the concentration in the atmosphere. Concentration, that's my dog in the background. Concentration in the atmosphere. Atmosphere. Okay, so that's E. Now let's get to the next question, so we can actually see. Okay, I'll print screen that. Let's scroll back up to here. Yeah, there you go. Okay, so I'm going to paste that in. This is part 2 to E. Outline 2 methods could be developed to achieve carbon capture and storage. So 2 methods. All right. It's not really. Do you know what? Let's see what my brush looks like. Okay, 2 methods. Actually that's kind of clear, isn't it? On the sea surface. So, outline 2 methods that could be developed to achieve carbon capture and storage. So you want a method of capturing of capturing the carbon on the surface of the seabed, or on the seabed, on the seabed. And the reason why I said that on the seabed, I'm talking about on the surface, is you can also store it. So that'd be your first mark. Your second mark would be also you could capture and store it under the seabed. And these are 2 completely different ideas. Oh, you know what? That paintbrush looks really nice. These are 2 completely different ideas, but it's such a simple way of saying it. Outline 2 methods that could be developed, and all you've got to remember is one is for the capture and storage on the surface of the seabed, and one under the seabed, and that's 2 marks there. The reason for it is by reacting carbon dioxide with metal oxides. And we all know this is going to form. So if that was metal oxides, we're going to form carbonates. Okay, right. I've just finished number 1. Just going to 2 ticks as I go terrorize that dog. Is that nice? Let's come over here. Oh, Olive the ostrich. Oh, do you know what? Coffee and walking around. Nothing better to stimulate the radio. Okay, right, where were we after this? So that was that question done. So, next bit is... Where are we? Let's get to the top. There we go. So let me have a sip of coffee. I still got 1 viewer. I think that is me, but I like it. I wonder if you can see this when I but anyway, we'll find out. We're going to see it when I finished. Okay. So coming back to this question here, enthalpy changes of combustion. Amongst it isn't changes to determine directly. Define, this is a 2 marker of the term. Oh, that is one strong question. Enthalpy change of combustion. Let me get my. I'm really enjoying that paintbrush actually. It makes my handwriting look so much neater. defined term, enthalpy change of combustion. Now, let's either understand it or memorize it. You guys have, well, basically no choice. Wow. So I'd pick one, but I would actually, no, I've lost it. Words everywhere. I'd try to understand it if you can't, because sometimes it takes a while to get your head around it. So the first part, the first mark I took, the enthalpy change for is the complete combustion, because in the previous question you looked at, you know, incomplete combustion, and you've got to say it's the complete combustion. The enthalpy change for the complete combustion, 1 mark, of, and this is the tricky bit, all right, 1 mole of a substance. It's something that, because most of you guys have all been doing this for one term, there's your second mark, and it has to be moles. The reason is it allows you to compare, reference, and look at, different compounds and elements. All right. I should carry down an experiment to determine the enthalpy change of combustion of pentan-1-ol. There you go. In the experiment, 1.76 grams of pentan-1-ol was burnt. The energy was used to heat 250 centimeter cubed of water from 24 to 78. Calculate the energy released in kilojoules during combustion. Specific density of water is 1 gram per centimeter cubed. Okay, now let's have a look at this. Oh, I think I might have to stop there because my daughter's getting a little bit. She's crying a little bit. Okay. Yeah, I think I'm just going to be disrupted. And I'll come back to that when I can. Right, thank you. Let's see what we got. Hangouts. Still one person. Let's end broadcast.